Now, one of the advanced techniques that's covered in the book is multiple regression. And we use multiple regression when we want to assess relationships between and among independent variables, as well as their relationship to the dependent variable. So this is a situation where I have multiple slope terms and multiple values of x all coming together to predict y. And so the regression equation in this case is going to be y is equal to the constant, okay, or the intercept term, plus the relationship between x1 and y, plus the relationship between x2 and y, plus error. So I am likely to have multiple slope coefficients, all that refer to different variables. This is variable x, and this is variable z. Now, in order to solve the slope terms for these coefficients, I take the standard deviation of y and divide it by the standard deviation of x, and then multiply it by the product of these terms here. Now, we don't have to go through the actual math. You're not going to be expected to, compute multiple regression coefficients. But you do need to understand that multiple regression is a technique that's used when we want to assess more than one independent variable at a time, and in particular, in interactions between independent variables and the relationship to a dependent variable. So the multiple regression equivalent to the coefficient of determination is called creatively the multiple correlation, or the multiple coefficient of determination. And it's capital R square, and it refers to the proportion of variance in y that's explained by all of the independent variables in combination. And here, in the event that you ever need it, is how you calculate this term. So again, for your purposes, for the assessments for this course, all that you need to understand is that multiple regression is a technique for when we want to assess the impact of more than one continuous independent variable on a dependent variable. Now, in terms of considerations when we're dealing with multiple regression, it could be the case that we want to look at the effects of a dichotomous variable in a regression equation. So for example, I might think that there's an effect of sex, in which case I'm going to code men as 1 and women as 0, or vice versa. I can then add in a dummy variable representing these group memberships into a regression equation, and that is done frequently. Second, as I alluded to in a previous slide, we can compute interaction terms. If I suspect that the effect of one variable is going to depend on another, then I can build those interaction terms. And always with multiple regression, multicollinearity is an issue. And this happens when variables that are in a regression equation are really highly correlated with each other, and it impacts which variable takes up certain pieces of the total variation. And so when we have multicollinearity, it's just something that we need to kind of make a note of so that we can make some statistical corrections. Now, all of these considerations are a little more advanced than your current needs for this course, but I wanted to include them because, number one, your book does an excellent job of describing these techniques, and some of you in research or practice in your future jobs might have situations in which you need a dummy variable or to build an interaction term. And so I wanted to at least provide some information about those topics.